Hi, I'm here to tell you about a new European project called GenTORE. My name is Nic Friggens. I'm a researcher with INRA in France, and I'm leading the project. And as you can see, it's a project about cattle, all kinds of cattle. GenTORE stands for Genomic Management Tools to Optimize Resilience and Efficiency across the bovine sector. So GenTORE started in June 2017, and GenTORE aims to develop the following things: innovative genome-enabled selection to optimize cattle resilience and efficiency in widely varying and changing environments. These tools which we want to develop should not just be incorporating genetic variables, they should also include other information, non-genetic variables, and be applicable across the full range of bovine systems, leading to an increase in system resilience. If we can achieve that, then we contribute to the economic, environmental and social sustainability of the European cattle meat and milk production systems. Talking about resilience and efficiency, these are things that we obviously want to increase. However, they are things which are difficult to deal with. So one of the first things we've set out to do is to start with some definitions. First of all, efficiency. Efficiency is fairly easy to define as the ratio of energy in the product relative to the energy that was ingested and used to achieve that product. However, something which is important is that this needs to be measured over a time period that is relevant to ensure that any gains we have in efficiency are sustainable. This is key because if we measure efficiency in the short term, for example by increasing productivity, but do not include the longer term consequences, we can end up with something which creates long-term problems. We know, for example, that selection for growth rate in meat-producing breeds has a negative impact on the resilience of adult animals. And likewise, we suspect that selection for higher milk yield is associated with decreased productive longevity. So it is important for us that our efficiency definition is a long-term efficiency and one that can be sustainable. Of course, the definition given above does not preclude the use of efficiency measures via residual feed intake type approaches. So efficiency we can define, even if we can see some challenges with respect to measuring it. What about resilience? The first thing with resilience is we need to think about what kind of animal do we want. Do we want an animal that is robust, that can stand firm in the face of challenges, or do we want an animal that immediately adapts? So we're talking about the oak tree on the one hand, or the reed on the other hand. I suspect the answer is we want a bit of both. What we do know is that we want animals that have the capacity to safeguard future ability to contribute genes to the next generation when confronted with environmental perturbations. What we're saying is that the animal should be able to live to fight another day. It should be able to survive challenges. It should also be able to successfully reproduce following challenges. And that implies a certain ability to adapt. It implies abilities to absorb an environmental challenge through buffering mechanisms, so for example using body reserves. It also implies an ability to readjust the allocation of the animal's resources in times of difficulty, down prioritizing non-vital functions to safeguard those that are important. So we're thinking about measuring resilience by looking at the rates of response of animals to challenges and the rates of recoveries. But there are significant challenges to doing this and to evaluating resilience relative to efficiency. So there are key issues. We need to better understand resilience and efficiency and their interplay. There are challenges for phenotyping them. Usually the things we want to measure are only easily done so in research stations. And then we want to be able to optimize the balance of resilience and efficiency in our animals according to local production environments. This is the whole reason for the GenTORE project. GenTORE is a consortium of 21 partners, not just research partners, but also multi-actor partners from 11 countries, which include all the major beef producing countries in Europe. You can see the list of partners below. And a key thing, or two key things, the project is multidisciplinary. It's not just geneticists, it's also socioeconomists, nutritional physiologists, modelers, and so on. And it's a multi-actor project, so there is active stakeholder involvement. And that is, you will see later on, very important for the project. So this is a bird's eye view of the GenTORE project. And you can see it has a nice, logical, connected structure. There is, moving from the left, a bunch of work to better understand resilience and efficiency biology in Work Package 2, linking that to description of local production systems in Work Package 1, and on-farm phenotyping. How do we make measures of resilience and efficiency in real-world situations? Those things feed into what we want to do on genomic prediction, moving towards multi-breed prediction of resilience and efficiency and multi-trait selection indexes. Work Package 4 feeds then into genomic management in Work Package 5. That is to say, we want to take this on-farm, provide on-farm management index for resilience and precision breeding. And then finally, to be able to ask the what-if questions in Work Package 6. So, to be able to model, to simulate the consequences of particular selection strategies according to local environments, to ask questions about system resilience in the face of changing environments, and so on. So all of that feeds through into the final Work Package 7, which is the interaction with the stakeholders, the outreach, the dissemination, and the training. I'm not going to go into detail of every single work package, but I will, however, put some spots on one or two work packages to give you a flavour of the kind of things we're doing. So Work Package 2 is about developing phenotypic tools as proxy. We would like to have efficiency and resilience of animals in real-world situations, in varying environments. To do that, we want to make use of existing near-market precision livestock solutions, such as accelerometers. We will link that with big data from national databases to allow us to contextualize the information we get from individual animals on individual farms. And finally, we will also incorporate some new technologies which try and overcome the challenges of making these kind of proxy measurements in extensive situations. It may be easy to do this for cows in a barn. It may be much more difficult to do this for cow on high alpine pasture, and that's where these new technologies may come in. Spot on the genomic prediction work package 4, the main tasks are to develop genomic predictions for resilience and efficiency for multiple breeds, for crossbreeds, and admixed breeds. To also look at the genetic contribution to variance in resilience and efficiency, and to move on to ask questions about G by E. There are some challenges here to do with available data, heterogeneity of data, but we're aiming to deliver something that can handle multi-breed and multi-trait models. So in this work package, we want to bring together the advances made on the genomic prediction with the advances made on the phenotyping proxies to allow on-farm precision ranking of female performance and resilience. The genomics information we can use to improve our mating with precision genomic matings. The phenotypic information will allow us to also take into account how well animals are performing in a given environment. And that clearly can have an added value for the farmer in his breeding and reproductive management. We want to deliver web-based tools for doing this, and we need to have some challenges sorted out about integrating these very different kinds of data, and also in the way that we describe things such as the environment. If you think about the technical objectives of this project, which are not only to exploit near-market technologies, but are also to develop the metrics for quantifying local production environments. We want to do that in terms that relate to their effect on animal resilience and efficiency, so that feeds more readily into the genomic part of the project. But we also want to do it in terms of the producer's innovation opportunities, his incentives for improvement, and so on. So those types of information represent a challenge because they are at different levels of description, they are more or less quantitative, and that is one of the things which will be important to bring together in the modelling work package. So GenTORE really has two narratives. The first one, which I've explained before, relating to maximizing the use of new genomic tools to allow us to breed animals for these complex traits, resilience and efficiency. And then the second narrative relating to the local production environments, which is the work package is now outlined in yellow, which is really about contextualizing this information and deploying it across different scales, different regions, different types of environment. And this is an area where stakeholder involvement will be extremely important. So stakeholder involvement in one picture is really to help us not just to build elegant solutions, but to build solutions that are useful. In other words, that the breeding industry can feed back and interact with the project relating to what are reasonable breeding goals, what are reasonable phenotyping strategies, but also the precision livestock industry, the advisory services and so on can have their say and their view on how we develop tools which answer real questions for farmers in multiple environments. GenTORE for me is a great project. It's a great multidisciplinary team and we have a great opportunity. We now, in 2017, just need to get stuck in. If you're interested in interacting with GenTORE, there's a Twitter feed, as you can see above, and there is also a website, www.gentore.eu. Please go and have a look. And with that, I would thank you for listening to this presentation.